We're going to look at, really, yesterday we did what I call the basic ones, kind of the easy ones. You just have X in them. And then we did some where you had to do some factoring in. Not that that's the end of the world. Today we're going to do some that have quotients in them. So you have variables on the top and the bottom. Not extra hard. I just got to show you how to handle it. And then we're going to do some absolute value inequalities, which also I don't think are too bad either. So back to the number line, all that good stuff. Okay, solving inequalities with quotients. Okay, so instead of making some big long list of process, I'm just going to show you how to do it. First things first, you want to, like when you factor, you want to set it to 0. So the first thing I'm going to do is subtract 1 over to my left-hand side. So minus 1. So just like when you have your factoring, set it to 0. Now, here is a throwback to an earlier section, like, oh gosh, we really technically are subtracting fractions. If I'm going to subtract fractions, we need to make a common denominator. Okay, so that's my next mission. So I see my common denominator. This guy has a 1 minus x in it, so it'd be nice if this had 1 minus x. So I'm going to times by 1 minus x on the top and the bottom. I'm sneaking it in there. I'm writing in the symbol. Because our goal is we want to combine or condense all of this to a single fraction. One term, just a top and bottom. That's it. So I'm just going to copy this guy down. I didn't touch it. And then, of course, I'm multiplying this red 1 through, but I mean, it's 1, so it doesn't affect it. Just FYI, we are multiplying it through. Now you have your common denominator. So I'm going to move it up here just so I'm not clear at the bottom. I'm going to fill in my common denominator. And I'm going to combine any like terms in the numerator. So 1 minus 1, those are going to cancel. X minus negative x. Careful on the signs there, minus and negative. You really have x plus x, 2x. So that's your first goal. That's the most time-consuming part you have on this. Is you A, have to set it to 0, B, you have to condense it then to a single fraction. Now, from here, it's kind of just like yesterday. We're going to get our critical points, our numbers to put on the number line, and then we have to test the number line to see if it's that and or. Now, to get your critical points, pretty easy. Since it's 0, it's a fraction, you set the top to 0 and the bottom to 0, which you can probably do in your head. I'm just going to jot it down for the first one. So I'm just going to pretend there's not the greater than, that it's just an equal. If I had to solve these, like I said, most of you can do it in your head. We're going to divide by 2, so we get 0. I'm going to add x over, so we get 1. So 0 and 1 are going to be my critical points. I'm going to set those on the number line, and then we have to do all the testing. You might want your calculators to do the testing to plug the numbers in. All right, just like yesterday, smallest to biggest, of course. 0, 4. So there's infinite answers, obviously. We've got our equal to, so I'm going to use close circles. And I'm going to start, of course, testing the number line. So I'm going to pick a number on the left of 0. Now, as always, it doesn't matter which expression you throw that negative 1 into. The original one, sometimes I do the original because I don't know. Is the door locked, Caleb? Will you? It might be, I don't know. So you could put the negative 1 in the original, or you could do the one set to 0. It doesn't matter. They're the same, they're just in different forms. Just because I'm standing on this side, I'm going to do the one set to 0. So I'm going to put negative 1 in there. So 2 times negative 1, 1 minus negative 1. So I'm going to just take a look at that. I've got negative 2 over 2, negative 1. Negative 1 is not greater than or equal to 0, so I am not going to shade that. Moving to the middle. Oh, God. I would probably use my calculator on this, because we're going to have to test a fraction. Let's use a half, or 0.5, of course. So I'm going to do 2 times a half. That I can do in my head, 1. And then 1 minus a half. So 1 minus a half, You can, again, of course, use your calculator. 1 divided by a half is 2. Hey, 2 is greater than or equal to 0. That works. I'm going to shade it. So like yesterday, 95-ish% of the time, your graphs are ands or ors. Pretty confident we got an and, but we should test it in case we have some weirdo, you know, all real numbers, no solution, something. I'm pretty sure it's an and, but I'm going to test. All right, let's put 2 in. So 2 times 2, 4. 1 minus 2, or negative 1 down there. course, that's -4, that's not greater than 0. So it is our and graph in the middle, and I'm just going to write it in interval notation because I think it's easiest. So from 0 to 1 for my final answer. So similar to our quadratics yesterday, but just to recap, start off the same, you set it to 0, but you have to combine it or condense it to a single fraction with your common denominator. That takes the most amount of work. Then to get your critical points to put on your number line, because you have a fraction, you're going to set the numerator to 0 and the denominator to 0. And you can do that in your head, of course. I just wrote it up for the first one. So let's do a couple more to practice. All right, first step, move 5 over. We have to set it to 0. I'm just going to subtract it. We don't need to write -5. Now, of course, because we're in fraction, I always write 5 in fraction form. It's 5 over 1, obviously. And let's make our common denominator. This is the time-consuming part of these. So first denominator, x minus 1. So we're going to put x minus 1 on this guy. Sneak it in there. Should have spaced it out a little more. So my first fraction we didn't touch. I'm just writing it in. This guy I'm going to distribute the 5 through. So 5 times x, 5 times -1. And the bottom, 1 times x minus 1. So same thing, we've got our common denominator, so I'm going to go ahead and fill that in. And I'm going to combine the like terms on my numerator because I want a single fraction. 2x minus 5x. 3 minus -5, so 3 plus 5. So get it set to 0, single fraction. Okay, from there, some of you can mentally do it now. To get your critical points to put on your number line to test it, you're going to set the numerator to 0, which we get a fraction out of that guy, and the denominator to 0. So this guy I'm going to subtract 8, divide off the -3, so we get 8/3, or 2 2/3 if you like that, and of course 1. And I don't care if you write out this work on a quiz or test. I'm just doing it obviously for your notes. All right, to the number line we go. All right, so smallest to biggest. 1 is the smaller of the two answers, 8/3. If you like that 2 2/3, that might be a little easier when you're picking numbers to test. Equal to. Okay, same spiel. I'm going to, of course, pick a number on the left of 1. I'm going to go 0. Now again, it doesn't matter if you test in the very original function or our 1 set to 0. Doesn't make a difference. They're the same, just different forms. Like 2/4, 1/2, same value, different forms. Because I'm standing here, I'm going to do this guy. So I'm going to put 0 in here. -3 times 0 is 0. 0 plus 8. 0 minus 1. So I have -8. Hey, -8 is less than or equal to 0. That's a win. A little shade of risky. Okay, let's pick a number in the middle. I'm going to pick 2. Seems like a good pick between 1 and 2 2/3. So 2 and first. -3 times 2, -6 plus 8. And then 2 minus 1. 2 is not less than or equal to 0, so that's no go. Pretty sure it's going to be an or, but let's test just to make sure. I'm going to put 3 in. -3 times 3, -9 plus 8. And then 3 minus 1. And of course, that's less than or equal to 0. So my hunch that it was an or was correct. Okay, so final answer. I'm just going to erase this little computation out of the way so I can put my final answer nice and pretty underneath. I'm going to go interval style, of course, just to kind of transition to doing that all the time. Smallest answer, -infinity. Then we stop here at 1, close circle, so a bracket, or use my little fancy intersection symbol there. Pick it up at 2 2/3, or 8/3, however you want to write it, doesn't matter to me on that. And we end at infinity. So any questions on B? Okay, I thought we'd just do one more because these are the trickiest. These out of the whole section are the most complicated because you have to do all of this lovely fraction work. So same process, set it to 0, combine the fractions, blah, blah, blah. So I'm going to subtract x over. Don't let it scare you, it's a variable. We're never scared, right? I'm going to go fraction style, obviously. Now, common denominator. So to make the bottoms match, I need an x on here. write it nice and pretty. So x times x, I'm going to combine it to x squared, 1 times x. So now I can combine this to one lovely fraction. Unfortunately, my like terms on the top, there aren't any. I'm just going to write in 2 minus x squared. So next up, I'm going to get my critical points to put on the number line. I'm going to set the numerator to 0. And of course the denominator. That one's easy. I got to do a little workarooski here on the numerator. I'm going to add x squared over. Here it's going to get fun. Get rid of squaring, we had a square root. The square root doesn't scare me so much, but we have to remember you're solving a quadratic and x squared. What's the little detail but critical detail that needs to be in front of our square root of 2? Plus or minus. So technically I have how many answers here? 3, it's one of those where we have 3. So that means we have 4 portions of the number line to test. Okay, fun, super fun. Let's draw the number line. I'm going to try to draw a little bigger one for this guy because we got so many numbers. All right, smallest answer of our 3 would be the negative square root of 2. Our middle answer would be the 0. And then our biggest answer, positive square root of 2. Now, don't let the fact you have a square root of 2 on the number line intimidate you. Of course, and it might be easier when you're testing too, I just happen to know it because I use square root of 2 all the time, it's about 1.41. So if it helps, think of that as negative 1.4. So I'm like, oh, I'm going to test negative 2. I'm going to test positive 2. Just because we have a square root doesn't mean we have to test square roots, okay? So don't let that scare you. So I'm going to test negative 2. Now again, it doesn't matter if you plug negative 2 in. Actually, I'm thinking I'm going to do the original one. I think that's a little less calculations. Or are simplified to 0, 1. Same thing, I'm going to do the original just to mix it up. If I put negative 2 in there, 2 over negative 2, and negative 2 for this one. So the question is negative 1 greater than negative 2? Sure is, shade it. I should put my open circle on there too. Okay, between 0 and negative 1.4. I'm like, okay, that seems scary, but we can actually test negative 1. That's in between them, that's not so bad. I'm going to put it in the original one. So I put negative 1 in there, 2 over negative 1. Is negative 2 greater than negative 1? No, not getting a shade, sorry, Belle. Okay, between 0 and 1.4. Ooh, boy, this is a kind of yuck one. We can do 1, that's not so bad. 2 over 1, 2. Then 1 in further right out. Oh, yeah, 2 is greater than. Put my open circles on here. And I'm going to test to the far right. I'm going to pack 2. So I'm going to have 2 over 2. 1 is not greater than 2. So this we have kind of the fun answers because you have 4 different numbers to test on the number line. Still easy. I'm still going to write my final answer in my interval notation, left to right. Smallest answer, negative infinity. Then we stop there, negative. I'm going to use root 2, the exact answer, of course, not the decimal. And then we have, or this other 0 to 2. Square root of 2, square root of 2, I should have said. There we go. So it's just a little time consuming when you have to test so many portions. That's the bad part of this. Any questions on that guy? All right, and then, sometimes I like to just put something on for a fun case, because why not, right? I know I said we're doing quotient. I know, this isn't a quotient. But I just wanted to throw it on. I was like, I don't want to make it a whole separate example. Let's just look at it. Okay, same thing. If you're like, man, I don't even know where to start. Well, all these quotients, all the quadratics we did yesterday, all of them I started by setting it to 0. I'm going to do the same thing. So I'm going to subtract x squared over. Okay, left side, not fractions, so that's nice. Not like terms. So a little stuck maybe. I'd try to use one of your favorite F words in math. Vector. You might have a different favorite F word, but we're just going to leave it at that. Now same thing, I'm going to get my critical points. I'm going to test the number line. Now, critical points, we're going to, probably already did it in your head. We're going to set x squared to 0, X minus 1 to 0. Yeah, two answers technically off of this, but plus or minus 0 is all 0 and 1. So I'm going to test 0 and 1. Okay. Same spiel, smallest to biggest on your number line. Greater than, so open circle. And let's test. I'm going to pick a number to the left. Now, of course, we don't need our calculator to put -1 in. Doesn't matter, of course, if you do the original or the set to 0, doesn't matter. I'm going to use this guy. -1 cubed, I'm like, okay, I got it. -1 squared is +1. So you got to be careful there. You got -2. Is -2 greater than 0? Of course it isn't. Okay, so nothing. So right now I'm thinking it's probably an and. Let's look. I'm going to try 0.5. So I would probably do this one in your calculator, 0.5 cubed minus 0.5 squared. Punch that in and figure out, is that going to be more than 0? I see some head shaking. See some no's, you're right. So I thought it was going to be an and, not an and. Okay, so clearly I wasn't right on that one, so that's why we got to keep testing. Let's try 2. So 2 cubed minus 2 squared. So I'm going to have 8. I can do this one without a calculator. 8 minus 4. 4. Hey, 4 is greater than 0. So this is, I just wanted to show you that sometimes you have these weirdo, unique cases happen where it's not always a nice, pretty and or an or. This time we just have the single, hey, from 1 to infinity works. Just wanted to show you one of those, like I said, 5% of the time they're ands and ors, and it's pretty straightforward, but I wanted to show you kind of a unique case. Elliot.
Never mind.
Okay. All right, that's my only spiel on that. Okay, absolute value inequalities. If you remember Algebra 1 from so long ago, there is nothing tricky, crazy, exciting, new about absolute value inequalities. Pretty much what you have to, and this is always true, this pattern does always work in absolute value. Less than always will be the ands, and it's just a matter of if you have the equal to on the symbol here, who cares? Greater is always going to be an or. So that pattern does always fall suit on our absolute values, just for the record. Okay, so let's solve these. These are nice. These are easy. So right away I see the less than symbol. I know it's going to be an and. Okay, nothing is exciting about that. Now, absolute value. Let's first talk about why it's an and. How do you get the second answer? Well, absolute value, remember, is the distance you walk from 0. The distance a number is from 0. I could go 5 to the right, 5 to the left, and you cover the same distance. Don't write this just to show you. If that was an equal sign, remember we would get our two answers. I'd set it equal to 2, and I would set it equal to -2. If it was an equal sign, because it's 2 to the right, 2 to the left, same distance. Our inequality here. Okay. Remember that -2. So first I'm just going to pull off the absolute value. Leave a little room here. I'm going to pull off my absolute value. I know it's an and answer. Less than's an and. So it's going to be in between 2 and -2. 2 to the right, 2 to the left, you cover 2 units. It's just a matter of direction, right, versus left. I'm like, oh, that's pretty easy to solve. I'm just going to add 5 everywhere. So I got 3, 7. So we're going to be in between 3 and 7. And it wants the number line. It wants interval notation. Yeah, I'll do it. So 3, 7, open circles, because we do not have the equal to, and we're in between. I'm going to do my interval. So that's the nice thing about absolute values. They're very straightforward. There's nothing crazy. Can you still test the number line and double check it's an and? Sure, but no need. Okay, greater, my English skills, greater, I know this is going to be an or. So to do our or, Ors, you always have to write the word or in it, okay? So clearly here we already have our positive 4. So that's gonna be our bigger one. Positive 4, my negative 4 expression I'm gonna write on the left. So my positive 4 I'm gonna keep on the right here. And we'll solve that. Now we could also of course be left, meaning less than or equal to negative 4. Because these always turn out to be an OR graph. So I'm just going to solve each one of these. I'm going to subtract 2 off. I'm going to subtract 2. We get a fraction there, but whatever. And remember OR here. And I'm just going to go to the number line. Thirds, less than, and let's just write out our interval notation because that's how what the directions say. So negative infinity to negative 2 or 2/3 to infinity. Now, one thing too, just to show you, because you're like, oh my gosh, there's so many different things to remember, the process where we're setting stuff to 0 and getting critical points and testing. How do I know when to do that? You could still do that same process on these guys if you're like, oh, I can't remember, is it and or? Let's say you're doing A, and you're like, I can't remember whatsoever, is it and or nor? So just like old school algebra 1, solve it, get 7, of course, and then set it equal to negative, that's a minus, set it equal to negative 2, you get the 3, you can put those on the number line and test it. If you pick a number like, I don't know, 4 in between it and plug it in, it will work, okay? If you pick numbers on the outside to test, they will not work. So if you're like, oh man, do I test? Is it and or I can't remember? You can still, like all the others, solve it, get your critical points, and test the number line. Just to show you, in case you forget, right? All right, last one. So this one just a little, I don't know, it's just a little messier because you don't have the absolute value symbols by itself, that expression. So I just need to do a little bit of work to handle that. So I'm going to start by subtracting the 5 over. So 3 minus 5. And then also, careful here. You've got this negative, think of it if it helps, like a negative 1 in the front. I want to get rid of it. So I'm going to divide it off. Careful. You're dividing both sides of an inequality by a negative. So I have to make sure I reverse my symbol. So this, I'm just going to kind of circle it here for a sec, is the actual inequality I'm now going to work on. So let's say, just to show you, like, oh man, I can't remember, is it and or, I'm freaking out, okay? Solve it like all the others. I'm going to get my 2 answers. 2x minus 1 equals 2. I'm going to do 2x minus 1 equals negative 2. And I'm going to test the number line. I'm going to go old school. So add 1, add 1. All right, divide by 2, great. We got a lot of fractions, but whatever. And now I'm just going to test the number line. 3 halves, just, I don't know why, whenever I'm graphing or I'm on a number line, I like it as a mixed number. So I'm going to make it 1 1/2, but you can leave it 3 halves, clearly I don't care. All right, equal to, so I'm going to go close circle. Now, we probably know right now, hopefully, if it's an and or an or graph, because it's a great or, okay? But let's say you forgot, test your number line. Pick a number on the left to negative 1/2. I don't know, negative 1. 2 times negative 1, negative 2. Minus 1, negative 3. Absolute value is 3, which is greater than or equal to 2. It's going to be an or. If you test 2 over here, that's going to work too. So if you ever forget, you can always test the old number line. Okay, interval notation. Negative infinity, negative 1/2, or got it. Okay, any questions on that? And again, I don't expect you on these absolute values to do all the testing and da-da-da-da-da. You can read the graph from the symbol. It's greater than, it's an or, less than is an and. Just FYI. All right, last couple things we have. Determine domains of the following, and then we're going to do a couple easy word problems. Now, domain. Domain comes up a lot in the world of math, obviously. Domain, remember, is what you can put in for x and, of course, get an answer out. We've talked a lot about square roots in here. Square rooting negative numbers, we now know, kicks you into the imaginary unit system. So we don't want to have whatever is underneath our square root. It's called the radicand for its fancy name if you want to know that. We always want this expression underneath our square root to be positive. So I'm going to be like, okay, I need x squared minus 25 to be over 0. Because if it's over 0, it's positive, I can square root it. Could you equal 0? Can you square root 0? What's the square root of 0? Yeah, so I'm going to slap an equal to on it. So now we're in an inequality, quadratic inequality that we have to solve. I'm set to 0. I see perfect squares. I'm going to factor, number line, test it. Now, some of you probably just knew the answers, but I'm going to factor it here for us, just, you know, do my due diligence. So I'm going to get negative 5 and 5. Number line. Put my closed circles because of my equal to. And I'm going to start testing. I'm going to pick a number to the left of negative 5, negative 6. Negative 6 squared, 36. 36 minus 25 is 11. Last time I checked, 11 was greater than or equal to 0. Looking good. So right now, your gut instinct, it's going to be what type of graph? 4. I'm pretty sure. Let's test 6. 6 squared, 36, minus 25. Yeah, You put 0 in, 0 squared, oh gosh, negative 25. That's not going to work. Okay, or graph. So let's write out our final answer here in our interval notation. Negative infinity to negative 5, or 5 to infinity. We're going to start talking more and more about domains and functions. So this is just kind of tying together. You can't square root a negative number, of course, and then our inequality solving. So same deal. I want my radicand, my expression under the square root. I want it to be 0 or over 0. I want it to turn out to be positive. Okay. Now, quadratic, we love to factor. Multiply to 6, add to negative 5. Got it. So my critical points, 3 and 2. And then we're just on the number line, testing away. 2, 3. And again, I don't care if you do the testing by hand or in your calculator, totally up to you. I'm going to pick a number on the left to 2. You know, just because I'm going to try to mental math it, I'm going to keep it easy. I'm going to put 0 on it. So like, ooh, 0 squared, out. 5 times 0, gone. I got 6. Yep, 6 is greater than or equal to 0. So I'm pretty sure it's an or graph. Pretty sure. I'm going to test 4 just to make sure. 4 squared, 5 times 4. So 16 minus 20, negative 4 plus 6. I got it too. Yeah, that's greater than 0. So it is our or graph. Okay. All right, negative infinities, our answer furthest to the left, then we stop here at 2, or then we pick it back up at 3 and all the way out to infinity. So domain, what you can put in the function for x, we want to make sure whatever's underneath is positive. Don't want to square root is negative, put you in imaginary units. All right, last thing we have, just like I said, a couple word problems. You've seen there's some word problems that pop up in this chapter. So a couple word problems with inequalities. Because you probably can see here, less expensive. We're going to have a less than symbol, okay? But still pretty easy. So carnival tickets, here we go. Carnival has 2 plans for tickets. Plan A, $5 entrance fee, 25 cents a ride. Doesn't seem too bad. Plan B, $2 entrance fee, 50 cents a ride. How many rides would you have to make for plan A to be less expensive than B? So I'm just going to kind of lay it out here. I want plan A to be less expensive than plan B. All right, so plan A, we have to pay the $5 plus 25 cents a ride. Now, I have no clue how many rides we're going to go on, so I'm going to say times X. Plan B, $2 to get in, and 50 cents a ride. And now I'm just going to go through and solve my inequality. So I'm going to get the x's on the same side, the numbers on the same side, you know, all the good stuff. So I'm going to subtract 2 over. I'm going to subtract the 25 cents over. So I have 25 cents over here. And then I hear you guys typing in your calculator, divide off 25 cents. Or mental math, 25 cents is a quarter, 1/4. 3 divided by 1/4 is the same as 3 times 4. What's 3 times 4? 12. Okay, so the question is, we got to answer this. It's a word problem, of course. How many rides would you have to take for plan A to be less expensive? And we have this for our answer. Now this kind of irritates me because inequalities, we like the variable on the left. So I'm just going to switch it around. Open part towards x. I didn't switch the symbol, I just changed the order, so x is first. So final answer, how many rides would you have to make for plan A to be less expensive? Is 12 an answer? No. Anything that is greater than 12. So I'm going to say more than 12 rides, over 12 rides. Can you write a decimal of a ride? No, you could say 13 or more rides. How are you going to say it? Short and sweet, I'm just going to say more than 12. Here's my final answer for that. All right, one last little word problem of the day. I thought I'd just throw a science one at you for fun, because we all love chemistry and science in here, right? No? No? Okay. Okay. So, instructions on a bottle of medicine indicate that the bottle should be stored at a temperature between, here comes our inequality, 5 degrees and 30 degrees. Inequalities, an and inequality. What range of temperature does this correspond to on the Fahrenheit scale? Okay, so first we want to be between 5 degrees Celsius. Celsius should get specific there. 30 degrees Celsius. So I'm going to kind of just set it up. We have to be in between 5 and 30. That's what they want to store them at. Now, here's the fun part. Do you know the formula from science class on how to convert Celsius into Fahrenheit? Elliot?
It's plus 32 times 1.8. I can't remember if it's in that particular order.
You're on the right track. I'm going to switch it. So Celsius, you're doing the opposite conversion. But same idea, same idea. So there's a throwback to science there for you. So all I'm going to do now, because it wants it on the Fahrenheit scale, so I'm just going to take this expression and throw it in here for Celsius. I'm going to use my 5/9 F minus 32. So, I mean, this is really not even that hard of a story problem, because now you just have the goal, or the problem, I should say, of solving for F. So, choices. Life's all about choices. You could distribute 5/9. I don't love that, because does it get rid of 5/9? I really just want to get rid of 5/9. So I'm not going to distribute it. I'm going to multiply by its reciprocal, 9/5. But of course I got to do that everywhere. You could distribute it, but I just assume get rid of it. So here my 5s cancel. This is all out of there. Here, I hear somebody punching in a calculator, but we should be able to mental math it. 5 goes into 36 times, 6 times 9. And then, of course, your final step, you're going to add 32 everywhere. Okay. So 9 plus 32, added up 41. Now, I'm going to make this look pretty for my final answer. I'm going to put a degree symbol on. And of course, we're in Fahrenheit. 54 plus that, I'm going to say, of course, what do we got? 86 degrees Fahrenheit. So, I don't care if you leave your final answer as that very lovely inequality. You can write out in words, it should be between 41 Fahrenheit and 86, as long as you have something indicating that. Throw back to science. For word problems, I don't think those are too bad, okay? So any questions on those last couple? All right.